Hi there, in the last video I went through the Newton-Raphson method and I also went through the derivation of the Newton-Raphson iterative formula. Okay. In addition, I also went through an exception to Newton-Raphson, so if you haven't seen that video I would encourage you to watch it. Okay. In this video I'm going to go through examples explaining how Newton-Raphson is applied. So here goes. So example number 1, let me underline this. Okay, so the question being, use the equation, and the equation is ln x plus x minus 4 is equal to 0. Okay, with x equals 2.5 as your first approximation, okay, so use the equation ln x plus x minus 4 is equal to 0 with x equals 2.5 as your first approximation, and we need to apply Newton-Raphson once, okay, to find a second approximation for the roots correct to 3 decimal places. Okay, so let me show you how the method works, or how the method is applied. Okay, so in this case, let me apply Newton-Raphson. Let me explain how this method works. So in step number 1, let me underline this. We have the equation ln x plus x minus 4 is equal to 0. Okay, and in the first step, okay, we need to write the equation. So if the equation is not of the form fx equals 0, rearrange it. But in this particular example, our equation is of the form fx equals 0. Okay. However, if it's not of the form fx equals 0, step number 1 is to rewrite given equation so that you're going to get a function on the left equaling 0 on the right. Okay, so that is step number 1. In our case, as I said, our equation is of that form, fx equals 0. So it's ln x plus x minus 4 equals 0, and this left-hand term is f of x. Okay, so we also have in the question x1. So x1 is what we call the first approximation. So the first approximation is 2.5. So we call x1 the first approximation, and x1 in this example is 2.5. So we'll need that also. And we'll need f of x, which is ln x plus x minus 4, and x1, which is 2.5 for this method. So first of all, f of x is ln x plus x minus 4. Okay, but for the Newton-Raphson process, we need to calculate f primes. So we need to differentiate f of x once. So if I differentiate once for f primed x, when I differentiate ln, it's 1 over x. When I differentiate 1x or x, it's 1. Okay, so that is step number 1. So step number 1 is to rearrange your equation so that you have fx equals 0, f of x is the function on the left hand side, and also work out the derivative f primed. Now in step number 2, let me underline this. Step number 2 is we need to work out f of x1 and also f primed of x1. Okay, so in step number 2, calculate f of x1 and f primed of x1. Okay, so in this case, f of x1, so our x1 is 2.5. So if I replace the x's here by 2.5, I'll have ln x, which is 2.5, plus x, which is 2.5, minus 4. Okay, so in this case, when you calculate f of 2.5, I had an answer of minus 0.5837. Okay, so that is the value that you should have for f of 2.5 or f of x1. And you also need f primed of x1, so f primed of x1. So remember, x1 is 2.5, so f primed of 2.5. So if I replace x as 2.5 in f primed of x, I'll have 1 over 2.5 plus 1, and that value is 1.4. Okay, so that is step number 2, work out f of x1 and f primed of x1. Okay, and the last step is step 3. So let me explain step 3. Let's underline that also. Step 3 is to use the Newton-Raphson iterative formula. Now, in this question, so this is the method if you're calculating the second approximation x2. Okay, you may need to continue you will need to continue the process to calculate further approximations, but this method is the method to work out the second approximation x2. Okay, so if we go to the iterative formula, xn plus 1 is xn minus f of xn over f primed of xn. So we need to calculate x2, so x2 will be x1 minus f of x1 over f primed of x1. Okay, if you want to work out x3, the third approximation, x3 will be x2 minus f of x2 over f primed of x2, and so forth and so forth. Okay, but in this example, we're calculating a second approximation, i.e. x2. So let me continue. So using Newton-Raphson, so I would encourage you to write the formula first. x2 will be x1 minus f of x1 over f primed of x1. So first write down the formula, okay, and then substitute your values. Okay, so let me continue, say over here. So x2 will be, now x1, that's given, that's 2.5. So 2.5 minus f of x1, so f of x1, answer to step 2, we had minus 0.5837. Okay, so minus 0.5837 over f primed of x1, and f primed of x1 we had 1.4. So divided by 1.4. So let's take a ruler, underline this. So once we calculate that, so we need to calculate that bearing in mind, so the question says to work it out correct to 3 decimal places. So I calculated this, and to 3 decimal places I had 2.917. So that is correct to 3 decimal places. Okay, so that completes this example number 1, and that is how Newton-Raphson works. So I broke it in terms of steps. these are the steps specifically to work out the second approximation, x2. But as I said, if you go back to the Newton-Raphson iterative formula to work out the third approximation, it will be x2 minus f of x2 over f primed x2. To work out the fourth, x4 will be x3 minus f of x3 over f primed of x3, and so on and so on. Okay? So that completes this example. Okay? Let's try another one. So example number 2. Let me take a red pen and a ruler, underline this. Okay? So the question is, use the equation. So we're going to use the equation hyperbolic cos x, and that is equal to 5 minus x, okay, with x is equal to 1.5 as a first approximation. Okay, and the question is, apply Newton-Raphson once to find a second approximation for the root correct to 2 decimal places. Okay, so let's have a go at this example also. So step number 1. So we have the equation hyperbolic cos x, that is equal to 5 minus x. So let's go back to the previous example. So I've written in red, rewrite this given equation so that you have fx equals 0. So you need to rewrite, bring all of your terms to one side, making the other side 0. So if I go back to this equation that we have here, if I bring these two terms on the right to the left, I'll have hyperbolic cos x minus 5 plus x is equal to 0. Okay. So as you can see, this whole term on the left hand side is my fx, which is equal to, of course, 0 on the right. So let me make a note that f of x is hyperbolic cos x minus 5 plus x, and the first approximation, so x1 is the first approximation given in this question, so that is 1.5. So x1, 1.5. Okay. Now, if we quickly go back to that previous example, example 1, we need to take f of x and work out f primed of x. So we need to differentiate once. So if we go to the current example, example number 2, f primed x, remember, when we differentiate hyperbolic cos, we get hyperbolic sine. Derivative of a constant is 0. However, when you differentiate plus x, it's plus 1. Okay, so this is what you should have for the derivative. Okay, so that completes step number 1. Let's move to step number 2. Step number 2, let's go back quickly to the previous example. In red, I said calculate f of x1 and f primed x1. So let's do that. So in this case, f of x1 is 1.5, so hyperbolic cos 1.5 minus 5 plus 1.5. Okay, and for this one I had a value of minus 1.148. Okay, and remember, if you want to get the hyperbolic functions in your calculator, there is a button HYP. So if you press that button, it should give you a list of hyperbolic functions, okay? So just in case, if you're wondering how to get hyperbolic cos of 1.5. So back to the example, to work out f prime of x1, if I replace the x's here by 1.5, I'm going to get hyperbolic sine. X is 1.5 plus 1, and that value I worked it out to be 3.129. Okay, so that completes step 2. And finally, in step number 3, so let me take a red pen and a ruler. Step number 3 is to use your Newton-Raphson iterative formula. So bearing in mind we need to work out the second approximation, that meaning x2. So to work out the second approximation, going back to the formula, x2 will be x1 minus f of x1 over f prime x1. Okay, so back to this example. So in this case, using Newton-Raphson, x2 will be x1 minus f of x1 over f primed x1. Okay, and if I replace what we have from the previous steps, x1 given in the question is 1.5, so 1.5 minus f of x1 from step 2 we had minus 1.148, so minus 1.148 divided by f prime of x1 from step 2, 3.129, so 3.129. And bearing in mind, in this question we need our answer to 2 decimal places. Okay, so I'll work this out to 2 decimal places. I had a final answer of 1.87, so this is 1.87 to 2 decimal places. Okay, so there you have it, another example just to show you again the method involved when you apply Newton-Raphson.